Greetings, my name is Kenneth. Welcome to my channel. The name of the channel is Results Oriented Preparation. What we're dealing with here is exam preparation and also tutoring, private tutoring, all specified for your needs. Remember, early preparation equals excellent results. Please watch the videos, give us a thumbs up, give us a like, subscribe so that you can get notification of our new and upcoming videos. Leave your comments and suggestions of all the new stuff that you want to see, either mathematics, statistics, economics, business management, and all other commercial subjects. Please leave your message, subscribe, and give us a thumbs up. Sharp. Okay, greetings. We are looking at variance and standard deviation today in statistics. Okay, now we are given here a data set starting with 243 and 292 up to 291. Now, this data set has already been arranged in ascending order, as you can see: 243, 259, 266, 274, 283, 289, and 291. All right, now for us to calculate the variance, first and foremost, we need to find two things. We need to find the mean, and we also need to find the sum of x squared values. Okay, let's say these values are x, right? If we say that these values are x, all right? Now let's list them down here. You've got 2, 4, 3. The next one is 259, and then 266, 274, as well as 283, and then next one is 289, and then finally 291. Okay, those are our values. Okay, if you want, usually you can put this in a table form, right? Put this in a form of a table. Put your ruler there. It's not all that neat, but anyway, put that in the form of a table. All right. Okay. That's where it ends there. Okay, now on this side we are going to put the squared values, the values of x squared, s squared. What it basically means is we're taking each of these values and square them there to get x squared. Now we're going to start with 243. 243 squared is going to give us there 59,049. All right, that is 243 squared. Next one, we've got 259 squared. That will be 67,081. All right, and then we go to 266. 266 is going to be 70756. All right, and then we go to 274. 274 is going to be 75076. Okay, and then the next one is 283. Now 283 squared, remember we are squaring these values. 283 squared is going to be 80,089. All right, and then the next value, which is 289, 289 is going to be 83,521. All right. And then the next one, which is 291, 291 is going to be 84,681. Okay, now these are the squared values of these figures. All right. Our next step then is to find the sum. Find the sum of these values. Find the sum of these values. The sum of these values means that we're adding 243 plus 259 plus 266 plus 274 plus 283 plus 289 plus 291. The sum of x values here is going to be 1,905. All right, that is 1,905. 1,905. All right, then we're adding that as well. The sum of x squared values. The sum of x squared values is going to be equals to, in this case, that is 520,000. 253. Sorry for that. 253. Okay, this is 520,253. That is the sum of those values there. Okay, now that we've got these values, now we go to the actual calculation. The actual calculation says variance, this is the formula, that is variance is equals to the sum of x squared, the sum of x squared, which is this sum here, minus n, which is the number of values in the data set, times the mean. All right, times the mean squared, divided by n minus 1. All right, now, so we've got this value, but we do not have the mean. So the next thing that we need to do there is to quickly calculate the mean. All right, we know that in order for us to find the mean, so the mean is equals to the sum of the values. All right, sum of n divided by n. So in this case, our mean is 1905 divided by 1, 2, 3, 4, 5, 6, 7 divided by 7. All right, therefore this will give us a mean of, quickly punch that in your calculator, you'll find that the mean is going to be 272,143. Okay, I'm bringing it to 3 decimal places, which will give you 272.143. This is the mean. All right, now we need this to compute there. We'll need this figure squared here. All right, we need the mean there, because as it is now, we've got the x squared, the sum of the x squared values, which is 520,253. We've got n, which is 7. We've got n, which is 7. The only item that we did not have for now is the mean. This is the reason why we had to add these values, because to find the mean, we are saying that the mean is equals to the sum of n values, sorry, the sum of x values, not n, the sum of x values divided by n. All right, sum of x values divided by n, which is the sum of all these values, which is 1,905, which we already found here, which is the reason why we calculated that sum here, divided by the number of values in our data set, which is 7, and that gives us that. Okay, now this was just a little detour showing you how to calculate the mean. Now we want to then go back to our variance there. go back to our variance. So let's just take this out for now. We know that our mean is 272.143. All right. That is our mean. Okay. So then, let's go ahead and do our substitution here. So our S squared, sorry for that, S squared is equals to, which is our variance. The sum there is 500, 520, 253 minus the number of values n, which is 7, multiplied by our mean, which we just calculated now, which is 272.143 squared, close bracket. All right, we divide everything here by 7 minus 1. All right, 7 minus 1, which is n minus 1. Quickly, you know that 7 minus 1 is 6. So you can skip this, but if you want to see exactly what is happening, you can skip that and just put 6 automatically there, because you know n minus 1 is 6. But anyway, we are substituting this so that everyone can follow and see exactly where we get our 6. Okay, so it's 7 minus 1 together 6. Now, if you then compute that, you will find a value of, this will give you variance is equals to 303.39. Okay, I'm bringing this to 2 decimal places. Now this is our variance there. Now that we have our variance, we can calculate the standard deviation. All right, the variance gets us to the point where we can be able to calculate the standard deviation. All right, now that being the case, then our standard deviation here is going to be the square root of the variance. All right, so standard deviation is equals to the square root of 303.39. Okay, the 39 is also under the square root. All right, so the square root of 303.39. Okay, that will give you a figure of standard deviation being 17.42. So this is 17.42. Okay, so that is how we calculate our variance and standard deviation. Now, to take note, things to take note here is this. The first and foremost is you need to find the sum of the values, which will help you get the mean. And also you need to find the sum of the x squared values, which you will substitute in your formula, which is variance is equals to sum of x squared values minus n, which is already given, because you just need to count the number of values in your data set, which is 7, and then the mean, which is given by this sum divided by the number of values, and in that case will give us that value there, and then you square it, and then n minus 1, and then you get that value. Once you've got the variance, then it is then easy for you to find the standard deviation. Now, the relationship then between the variance and the standard deviation is that for you to find the standard deviation, you need to square the variance. All right, so the standard deviation is a product of the square root of the variance. All right, once you have the variance, then you are closer to your standard deviation. That is the link that is there. Okay, go through it. If you've got any questions relating to this or any statistical problems, please don't hesitate to leave a comment below. Give us a like for this video if you like the video. Give us a thumbs up. Okay, all right, sharp. Remember always, early preparation equals excellent results. That is why we are focused on this for a results-oriented preparation. Sharp.